There are some facets of robot performance that cannot be shown with a bar chart. Some fields, like accuracy, are actually misleading if shown that way. In this video, we will make some more advanced visualizations to help us answer more complicated questions. We will also learn how to find trends in robot performance. The first graph we are going to create is an accuracy graph like this one, but for autonomous period. This is not a very hard graph to build, but in order to create it, we need to write a new calculated field. In its simplest form, accuracy is the number of hits divided by the number of shots taken by a robot. In this case, we can get this by adding up autonomous 2, 4, and 6-point shots inside of these parentheses. Then copy and paste them, but add in autonomous missed shots. If we divide the first group by the second group, we get hits divided by shots, or our accuracy. To graph this, let's start in a familiar format, the bar chart. Drag team number to the rows and autonomous accuracy to the columns. Remember to turn autonomous accuracy from a sum to an average, because the sum of accuracy doesn't make sense. These 16 nulls down here are teams that never shot. We can filter out this data. There seems to be far too many teams with 100% accuracy. Whenever the data seems off, we can always drag in additional fields to see what's causing our data to be weird. In this case, let's drag in autonomous score to label. As I thought, a few teams are sneaking in because they didn't shoot very many times. If we want our data to be more clear, to avoid teams like this sneaking into the top of our graph, we can change this bar chart into a scatter plot. To do this, drag autonomous score to the rows shelf. Tableau creates a scatter plot for each team. If we want all of our teams to be on the same axis, drag team number to label. Now all of our teams are on the same axis. To make our data a little bit more pretty, I like to change the marks from automatic to circle and the color to about 50% transparency. Now we can see when teams overlap. A team that shot more times and still has 100% accuracy is much more impressive than a team that only shot a few times. If we want to also show how many shots a team made, we can create a calculated field for that. To find the number of shots taken during autonomous, add up autonomous 2, 4, 6, and missed shots. This is basically what we did in the autonomous accuracy calculation, although just by itself. Let's drag autonomous shots onto size. Also, let's make the size a little bit bigger so we can see the differences between the teams. Currently, auto shots is set to sum. The sum of auto shots is the sample size. This is very useful for finding how reputable a team's accuracy is. If we want to find out how many shots they make per match, we can change sum to average. Most of the graphs we have made so far are really good at showing what a robot has done in the past. If we want to find out what a robot might be expected to do in the future, we can make spark lines. To make spark lines, drag team number to rows. Then drag match number to columns. Then change match number from discrete to continuous. As you can see, each of these bars shows a match where that robot played in. If we want to graph the trend of a field over time, drag that field to the rows shelf. Tableau now shows us how teams perform over time. If we want to build a trend off of this, we can right-click and have it show us trend lines. The slope of these trend lines is useful for seeing if a team is improving, getting worse, or staying steady. Just like the stacked bar charts, we can sort spark lines by whatever field we want by going to team number and sorting it. Spark lines are very useful for alliance selection. As we can see, most of these teams are improving. However, when we get down to picking between a team who's getting worse or a team that's improving slightly, it's usually smart to pick the team that is improving. A downward sloping trend line sometimes shows that a robot is wearing out. An upward sloping trend line shows that a team is learning how to control their robot or is fixing things. Besides alliance selection, we can use trend lines to assume if a robot will perform a little bit above or below its average points the next game. Making trend lines for autonomous score is especially useful for finding out if a team has developed a new autonomous routine or has fixed things. For instance, this team probably developed and mastered their autonomous routine around match 30. Remember that because we have written new calculated fields, we should resave our data source so we don't have to type them out again later. These different graphs are just another tool that we can use to improve the clarity of our data. Because scatter plots don't take very much longer than bar charts to create, we should use them whenever it can help us. Thank you for watching this video.